Due to the grinding, uh, continued grinding, the bore size increases, and at one point of time, the gauge B enters into the bore. At that point of time, there will be contact made by E2, which actuates wheel dressing cycle. And then the diamond pointer comes into position, and it addresses the wheel so that a finishing cut can be given. During finish grinding, gauge A tries to enter. When the correct size is reached, gauge A will enter. When A enters, it actuates another contact even. This is also uh, contacted. Now, when contact E is made, this will activate a relay, and the grinding wheel is withdrawn and the machining stops. Now let us study an auto sizing device meant for inspecting interrupted surfaces. This is basically an electro-pneumatic unit, so wherein compressed air is used for measurement purpose. So here you can see the anvil wherein we have jets. I'm just writing this, I'm enlarging this portion. So here there will be a nozzle, and air, compressed air will be escaping, and this is the workpiece, a spline shaft, being ground. Now, so in this spline shaft, we get uh, two pressures. When there is land in position, the gap between the nozzle and the workpiece surface is less, and hence the back pressure is more. When the space comes into position, that means when the space comes into position, the gap will increase and the pressure will reduce. So this electro-pneumatic unit is capable of distinguishing between the pressure, the increased pressure, and the reduced pressure. So in the schematic diagram, we can observe that two open jets are mounted in a non-contact type caliper gauge. When grinding commences, the gauge head is away from the workpiece. That means this gauge head is in the retracted position until the component is within 0.5 to 0.1 millimeter of the required size. Now you can see when the uh, workpiece size comes within this range, within the 0.5 to 0.1 mm of the required size, the gauge head is moved to the position by operating an air cylinder. At this stage, an electrical signal is produced, and the gauge head advances the measuring anvils to the preset position. Now you can see these dashed uh, gauge heads indicate the gauge head is in position. Grinding continues. When the correct size is reached, the gauge head sends a pressure signal to the controller to withdraw the wheel head. That means when the pressure, uh, when the size of the workpiece splined shaft approaches the correct size, there will be a certain pressure, and when that pressure is equal to the preset pressure, a pressure signal is sent to the machine control unit, which will withdraw the wheel head. An accuracy of 0.0005 millimeter is possible with a system like this. Now we can observe from the diagram that knurled B and thimble D. So this is knurled wheel B and this is the thimble that is D. These are used to adjust the gap between the gauge head anvil and the spline surface. The system differentiates between the large and small variation in pressure which occur alternatively as the spaces and lands of surface pass the jets. Pressure variation is applied to a sensitive capsule carrying a set of contacts which breaks a relay circuit when preset pressures are reached and wheel head is withdrawn. Like this electropneumatic circuit works. Now, let us study a system which is used to gauge the turned workpieces, and this is called dizzy turn lathe system. And this system is preset using a master workpiece. Direct reading of dimensions can be obtained by reading this display unit. Now we can observe from this diagram that linear encoders are used for the two axes x and z. For x-axis there is a linear encoder, and for y-axis for z-axis there is a linear encoder, and we can get the direct reading from the display panel. And using a master workpiece we can set the values. Preset values can be input to the system. So you can see the two buttons are there for setting 0 when the masterpiece is used. All measurements are with reference to the preset data. The machine runs continuously and operator stops the machine when the desired size is reached. That means the operator will be observing the readings in the panel. When the correct size is reached, he will stop the machine. Now here we can see the linear encoders. You can see this is one linear encoder fixed to the lathe bed. This is for the z-axis, and similarly for x-axis there is a linear encoder, and this is for z-axis. And you can observe the appearance of linear encoders, and this is the display. This is for x, and this is for z. Turning continues, the values, the radius and length values are displayed here, and the operator will be observing. When the correct size is reached, he will stop the machine tool.